Hello all, we all know that PCB plays a very crucial role in embedded products, right? Designing a PCB is a very important step. Now, while designing plays a crucial role, manufacturing the PCB and assembling the PCB also plays a crucial role. So, during the PCB design stage, selecting the right PCB material is very important. Now, most of the embedded products, if we don't go to the complex domains or high speed domains, if we talk about a generic commercial products, most of the low speed embedded electronics use FR4 material, right? In FR4 material, most of the guys use isola, right? Isola FR4. So this FR4, where we all know that these PCBs have a rating called flammability rating, which is UL94, which is as per UL94 spec. So, in this UL94 spec, there are three things: UL94 V0, V1, and V2. So, when you check the specs, right, what they explain to us is whenever a PCB catches a fire, okay, there is every chance, right, you might get a shot on the PCB, electronics might catch fire, and when it catches fire, the ability of this particular PCB material to actually resist that fire, or it actually catches fire and it exhausts by itself. So these cases are what are explained or what are important as per UL94 spec. So if you take, for example, UL94 V0, which is a very common FR4 material spec which we take, UL94 V0, what it states is whenever a PCB catches fire and when the source of the fire goes off, the PCB should not hold fire for more than 10 seconds. That, if that is true, then it is compliant to UL94 V0. So most of the FR4 boards we use are compliant to UL94 V0, and it is very important that we check the specs from FR4 datasheet and ensure that the spec is present, and so that this is all related to the safety of the individuals using electronics, which the materials are providing us, right? So PCB is very important. At the same time, safety of the guys who are using this PCB, or safety of the guys when it is used in a product, is very important. Now let us look at this particular PCB and try to give fire and see how it is reacting to the scenario. Let us look at it. So we have a fire that is here, and then we are trying to have this PCB, and we are applying a constant fire to this particular PCB. Okay, so as we see here, there is a constant fire that is being applied to this PCB, and this particular PCB is of FR4 material. Okay, so we are just trying to apply constant fire to this particular PCB. Now we can see the burning smell that is coming, but okay, so now we removed the fire, after the PCB caught fire, and you can see automatically it got extinguished. Now again we are just trying to apply, and I could feel the same burning smell which comes out of the PCB, right? Whenever we short a PCB, the same kind of burning smell is seen here. Okay, so again I'm just trying to apply the constant fire here to this particular PCB. So at least what is observed as per the analysis is, even though it catches fire, within a fraction of seconds the fire gets extinguished by itself. Okay, so we can apply fire for a longer time, but just at least the initial analysis or initial um, experiment shows that the fire doesn't um, hold on for a very long time, and at least it is as per the specs of UL94 V0. We can keep under constant fire for a very long time and even observe. Okay, thank you.